My name is Mr. Folashade Oluwasegun Ajewole. The topic we'll be considering today is laws of chemical combination. In all, there are 4 of these laws for chemical combination, which describe the general features of a chemical reaction. They are: 1. Law of conservation of mass. 2. Law of definite proportions. 3. Law of multiple proportions. And 4. Law of reciprocal proportion. The first of these laws, the law of conservation of mass. This law states that matter is neither created nor destroyed during chemical reaction, but changed from one form to another. This law, it then means that in a given chemical reaction, the masses of both the reactants and the products are the same. Take for instance, during burning of coal, if we weigh the mass of the two reactants, that is the piece of coal and all the oxygen which reacted with it, and that of all the products, which includes water vapor, carbon dioxide, ash, soot, and others, we will find out after all that there is no loss or gain of mass. This law is widely applied in balancing of chemical equations. Take for example that equation of magnesium reacting with 2 moles of HCl to produce 1 mole of magnesium chloride and 1 mole of hydrogen gas. Now, if you look at this balanced equation, observe that the number of magnesium atoms that reacted is the same with the number of magnesium atoms produced, 1 in each case. And when you also look at the number of hydrogen and chlorine atoms that is involved at the reactant site in HCl, which is 2 in each cases, you find out that it's the same in magnesium chloride and hydrogen gas molecule that is produced, in each case 2 of chlorine and 2 of hydrogen atoms there. Now, it is revealed that atoms is neither created nor destroyed, and therefore matter is neither created nor destroyed in this chemical reaction and in all chemical reactions. The second law of chemical combination we'll be considering is the law of definite proportions. This law is also known as the law of constant composition, and it states that all pure samples of a particular compound contain the same elements combined in the same proportion by mass. This law explains the fact that pure samples of all compounds are identical in composition by mass, irrespective of their sources or the means of their preparation. This is because when elements combine to form a given compound, they do so in fixed proportions. Some calculations are involved under this topic, and we'll look at a worked example here. Example 1. 2 samples of iron 2 sulfide were prepared by A, heating a mixture of iron filings and sulfur, and B, passing hydrogen sulfide gas into a solution of iron 2 chloride and filtering. Analysis of both samples of iron 2 sulfide showed that in A, 0.8 gram of sulfur combined with 1.4 gram of iron, while in B, 5.5 gram of iron 2 sulfide contained 2.0 gram of sulfur. 1. Write the balance equation for the reactions in A and B. 2. Show that these results illustrate the law of constant composition. Solving this question, the reactions in A is given as Fe plus S to give FeS, where F is stand for the iron, then S for sulfur, and the iron 2 sulfide produced as FeS. And the reaction 2, we have H2S plus FeCl2 to give 2HCl plus FeS. Now the second question. In the question you are given the mass of iron and the mass of sulfur in sample A, but in sample B you are given the mass of iron sulfide and the mass of sulfur. Now to get the mass of iron sulfide in sample A, you have to add mass of iron with mass of sulfur, since matter is neither created nor destroyed. So then to get the mass of iron, you will subtract the mass of sulfur from that of mass of iron 2 sulfide, and that gives us those values as you can see. The percentage by mass of iron in sample A is given as 1.4 gram all over 2.2 all multiplied by 100, and that gives us 63.6%. Then you calculate the percentage by mass of iron in sample B, which is given as 3.5 all over 5.5 gram all multiplied by 100 to give you 63.6 as well. And that implies that the percentage of sulfur in both samples will be 36.4%, having subtracting 63.6 from 100. Now when you look at these results properly, you will observe that the samples of iron 2 sulfide contains the same element, iron and sulfur, in the same proportion by mass, and hence the law of constant composition is illustrated. The third law of chemical combination is the law of multiple proportions, and it states that if two elements A and B combine to form more than one compound, then the various masses of A which combine with a fixed mass of B are in simple whole number ratio. Again, let's quickly consider a worked example. Two oxides of sulfur, A and B, were analyzed, and the results obtained showed that in oxide A, 3.50 gram of sulfur combined with 6.00 gram of oxygen, and in oxide B, 2.80 gram of sulfur combined with 9.55 gram of oxygen. Show that these results illustrate the law of multiple proportions. The best way to go about the calculation under this law of multiple proportion is to analyze what you are given in the two compounds. In this case, oxide A and oxide B. You analyze the mass of sulfur and the mass of oxygen as given in the question. And in this case, for oxide A, 3.50 gram is given, mass of oxygen is 6.0 gram in oxide A, and in oxide B, 2.80 gram for mass of sulfur, and the mass of oxygen is 9.55 gram. Now you have to have a fixed mass of one of the elements, and in this case we are considering sulfur. Any number could be a fixed mass. In this case we are also considering 10.0 gram. Now from the values that you have, we have that in oxide A, 3.5 gram of sulfur combined with 6.0 gram of oxygen, which implies that if 10 gram of sulfur have to combine with oxygen is going to combine with 10 times 6.0 gram divided by 3.5 gram, and that will give us 17.0 gram. Then in oxide B, in the values given, it is noted that 2.80 gram of sulfur combined with 9.55 gram of oxygen. Then the fixed mass, which is 10 gram of sulfur, we have to combine with 10 times 9.55, that's like a cross multiplication, divided by 2.8 gram, and that gives us 34.0 gram. These calculations gave us the masses of oxygen in oxide A and oxide B that have combined with a fixed mass of sulfur. And looking at it, if we calculate it into ratio by dividing by the smallest, we have 17 to divide both values, which is 17 and 34, and that will give us a ratio of 1:2. And since it is now a simple whole number ratio, it implies that the result illustrates the law of multiple proportion. The last but not the least is the law of reciprocal proportions. It's not all that common, but this law states that the masses of various elements A, B, C, which combine separately with a fixed mass of another element D, are the same as or simple multiples of the masses in which A, B, C themselves combine with one another. To wrap up this lecture today, are these two exercises you can attempt to test whether you understood the subject or not. And there are two questions there. Read them, attempt them, and forward your answers to us and through our phone number. We hope you have a good time, and we wish you best of luck in all your endeavors. Good day.